Okay, hi everyone. I just want to do the first of the applications videos. Okay, applications. Let's look at a couple of applications. Okay, the first application I want to show you is very, very similar to the worked example. It's example 4.10. Yeah, okay, and that's on page 118. It's on page 118. Okay. But I'm not going to do that one. I'm going to do instead question 2 on page 119, primarily because the answer in the book I think is wrong. So I'm just going to do this now. So this is what we're trying to find is this integral, which we can't normally do, and we're just going to approximate it. So we got cos x cubed minus 1 divided by x squared dx. So first of all, and I have to write this in a series form. So I've got to do this integral, and my answer has to be as a series. Okay, so the first thing I'm going to do is I'm going to write down what cos x is. So you remember what cos x hopefully is. Cos x equals, this is in your data book, but anyway, it's 1 minus x squared, on 2 factorial, plus x to the power of 4 on 4 factorial, minus dot dot dot. And we can write that as a sum if you remember. That's the sum from 0 to infinity of minus 1 to the power of k. What was it? It was x to the power of 2k divided by 2k factorial. Okay, now what I'm going to do is I've now got to substitute in, so I'm just going to change my pen here. I've now got to substitute in for x, so I've got to replace x with x cubed and subtract 1 off. So that's what I'm going to do here. So I'm going to do this all. I'm going to do cos of x cubed, and then what I've got to do is I've got to subtract 1 off that. So I've got to take this series here, okay, and basically subtract 1 off. So if I take 1 off from that series, guess what? There goes. Okay, and I've got to replace all of these x's here with an x cubed. So that becomes, my first term becomes minus x cubed squared is x to the power of 6 on 2 factorial. X cubed to the power of 4 becomes x to the power of 12 on 4 factorial, and so on, so on, so on. Minus dot 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 dot, and that's going to equal to, if you notice, because I haven't got the 1 anymore, I can just start at that 1 and go to infinity, and this will become minus 1 to the power of k, and what I've got here is x to the power of, now really I could have just put x cubed in there, x cubed to the power of 2k becomes x 6k, okay, and then that's divided by 2k factorial. So that's just the first part, right? Now, in the next part, ladies and gents, what I've got to do is I now have to divide that by x squared. Okay, so that's basically what I'm going to do. So I've got the integral. So basically I'll use my first equal sign down there. So from that, we'll just come down here and I'll use my first equal sign. So that's going to equal to, I've got to divide by x squared. So I've got the sum from 1 to infinity of minus 1 to the power of k, 6k on 2k factorial, and then what I've got to do is divide that by x squared. So there's my x squared there, dividing by x squared, and I've got to find this integral dx. Okay, now dividing by x squared is just going to subtract 2 off that power. So let's just come up here and do that. So that, now the other thing too is you will remember, anyway, cos x converges to that series for any single value of x. So we can take that integral sign and place it inside the summation sign. So we end up with the sum from 1 to infinity, of the integral of minus 1 to the power of k, x to the power of 6k minus 2, that's because I've just divided by x squared, divided by 2k factorial dx. And now let's do that integral, which just means adding 1 to this power and dividing by that same power. So I end up with, this becomes 1 to infinity, minus 1 to the power of k, x to the power of 6k minus 1, because I've had to add 1 to that, and then I divide by that, which is going to be 6k minus 1 2k factorial. Now that's different to what they had in the answers, okay? I think they just had, I'll just show you what they had in the answers. I think they just had this bit here in the answers. They haven't actually done the integral as yet. But of course, you must do the integral, and that's the correct answer there. Okay, so if you want to now, if I were you, I'd go on and do question 2b just to practice that one question type.